So the bipolar, the modification of the bipolar line coding technique is known as the HDB3. So that is what I specified earlier also. That is plus A. That is odd number of ones. It is going to have the amplitude level plus A. Even number of amplitude levels. Even number of ones is going to have the amplitude level as minus A. And the 0 is going to have the amplitude level 0 volts. So for that, when it is going to be received, the consecutive zeros at the receiver, it is very difficult for to received signal at the receiver to detect if consecutive number of zeros are going to increase. So for that reason we go for HDB3 code. So what is this HDB3 code? It is high density bipolar of order 3. So 3 is indicating order 3 is nothing but more than 3. If it is received as 4 zeros, then change the code. Then the change. So if at the receiver side, if it is going to receive more than 3 zeros, more than 3 consecutive zeros, then this code is applicable. What it is going to have, it is going to give, that is, if for more than 3 zeros it is going to be, then in place of 4 zeros, in place of 4 zeros, it is going to substitute as, this is going to be replaced as 00V. So this is going to be replaced as 00V. So if that depends on, there are two code you are observing at the screen. One is the B00V, the other one is B00V, the other one is 00V. So where it is nothing but when you are going to receive the even number of ones before this consecutive 4 zeros, then it is the code is B00V. If it is received as odd number of ones, so if before the consecutive 3 zeros, that is 00V. So the plus is going to be indicating, that is previous ones. If it is plus is received as a previous one polarity, then it is minus 00 minus. If it is received as a negative as the polarity, then it is plus 00 plus. So now if it is a odd number of 1 before the consecutive 0, so then 00V. If before 1 the consecutive 0, what you are going to consecutive that is 1 before the consecutive zeros, if the polarity of that is going to be positive, then it is 00 plus. The polarity of this is going to be negative, then it is 000 minus. Okay, so the next thing is to consider an example, so where it can be implemented and how it can be implemented. So this is one example you are able to see, that is 1 followed by 4 zeros, 1 followed by 4 zeros and 1 1 0. So here you can see in the 4 0 place, I can write it as 0 0 0 0 V, 0 0 0 V. So now the code becomes now 1 0 0. Okay, so 1 0 V 1 1 0 1 1 0. Now the code is 0 0. V is going to substitute in place of the 4 zeros, in place of 4 zeros. So now the code is 1 0 0 0 V 1 1 0. So now depending on the polarity, if I choose the polarity of this is as the plus, then the polarity of V is going to violating. V stands for violating, B stands for bipolar or balancing bit. Okay, so it is 0, so 0 0, it is going to follow the same polarity of it, that is going to have the polarity, it is plus. It is actually from the bipolar rules it has to be negative, but it is violating the rules of bipolar, so it is going to retain the same polarity what is in the previous one it is going to have. Now the code is next one becomes, since the previous is positive, it becomes the bipolar bit, then it becomes a negative, the next one becomes positive, and the last one 0 as it is. So now this is the signal, or the electrical signal is going to electrical waveform. It is going to so now the polarity of the bit stream becomes plus 0 0 plus minus plus. So this can also be drawn in form of a waveform. So that is plus is the positive value, then 0 0, 0 0, then again it is positive, again it is negative, again it is positive, and this is going to be a 0. So for this you can say that for this next example, so what you are observing, that is 1 0 1 followed by 5 zeros, followed by 2 ones, followed by 4 zeros, double 1 and 6 zeros. So this 5 zeros can be replaced as these 5 zeros. So here I have written here. So this 5 zeros can be replaced as, so here it is 1. Okay, so these 5 zeros can be replaced. The first is considered as the odd number of 1. So I'll give the so I'll retain here. So in place of after 3 zeros, I'll take it as V, since I am considering it as the odd numbers. So here it is the even number of 1. This is going to have the value of B00V, and here even number of 1. Now the first 4 zeros becomes 0 0. Sorry, first bit is B 0 0 V double 0 V double 0. So now what is the polarity of it? And then you can also write here, you can see. So the coding is plus 0 minus, so it is 101. Okay, 101. So the first polarity, it is considered as the plus. Okay, so next one as negative. Okay, so the polarity of it becomes 0 plus 0 minus triple 0 minus 0 plus minus plus 0 0 plus minus plus minus 0 0 minus 0 0. So this is about the HDB3 line coding technique. If the receiver received, this is a modification of a bipolar line coding technique to avoid the consecutive zeros, so that at the receiver it can be decoded properly. Next. So this is about what we discussed so far. It is about the B3 ZS coding. So the next is about HDB3. Now it is the B3 ZS. It is nothing but in the HDB3 line bipolar line coding technique, as I mentioned, it is going to use for the E carrier telephone signal. So whereas the B3 ZS coding is going to be used for T carrier telephone channels. So for that reason, this is going to be used in the North America. So where it can be a T3 rate, it is going to have transmit 44.736 megabits per second. So the bipolar violations are inserted if 3 or more consecutive zeros occurs. So this line code is called the bipolar with the 3-0 substitution, and it is very similar to HDB3. Each run of 3 consecutive zeros is replaced by 00V or B00V. The choice is made to ensure that the consecutive violations are differing polarity, that is separated by an odd number of normal B marks. So here we are going to consider, three zeros. We are considered only the 3 consecutive zeros. So depending on the odd number of 1, this 0 may have decoded as B0V or else 00V, or else it can be decoded as 00V. So that is what, if it is received odd number of 1, it is 00V. Even number of 1 before the consecutive zeros, it is considered as B0V. So now polarity of last bit is positive, then the polarity, the coded polarity is 00 plus. If the polarity of ones is previous one is 1, then it is the 00 minus 1. Plus 1 is minus 0 minus, and if it is received as minus, it becomes 0 plus 0 plus. Okay, so this is another line coding technique which can be considered, that is the B8 ZS is nothing but when it is going to be the bipolar signal is transmitted through the 8 consecutive zeros, so then the coding technique is, what is the coding technique? It is 00VB 0VB depending on the polarity of the preceding mark. Okay, so that is if it is polarity is positive, then the 00 plus minus 0 minus plus, or else it is 00 minus plus 0 plus minus. So that is what the polarity. If it is here in this case for even number of 1, here in this case it is for odd number of 1. So the commonly used North American T1 channels having the line code, which is the capacity of 1.544 megabits per second line code, which is uses the bipolar with the 8-0 substitution. In generally, it is also known as the BN. It is also known as the BNZS coding. It is nothing but bipolar N0 substitution. Bipolar N0 substitution. So here we have considered earlier we have considered 3 zeros. So now I am considering 8 zeros. So for the next it is considered as the B6ZS. So which is going to be used for the T2 carrier. It is going to be used for the T1 carrier. Earlier it is for the T3 carrier. So now at the North American T2 rate, that is 6.312 megabits per second, bipolar violations are inserted if 6 or more consecutive zeros occurs. So this line code is called the bipolar with the 6-0 substitution and replaces with the 6 consecutive zeros, and the pattern becomes 0VB, 0VB depending on the polarity of preceding marks. So that could be 0 plus minus 0 plus minus, or 0 minus plus 0 plus minus. Okay, this is about B8ZS and B6ZS. So if you move on to the example considering the B3ZS, the code pattern is here, that is 101, 00, 11, 0, 000, 000, 001 and 001. So here in this case we can observe that plus 0 minus and 00 minus plus minus 101, that is plus 0 plus, and 0 minus 0 minus 0 plus and 0 plus. So the case 2 it is plus 0 minus plus 0 plus minus plus 0 minus 0 minus and plus 0 plus and 0 minus, and it is 0 minus. It depending on case 1 and case 2 is depending on the previous one what you have considered, whether it is odd number of 1 or else whether it is a even number of 1. Okay, so this is the waveform, that is what the polarity of the signal can be represented using the waveform. So this is example, that is 101, 4 zeros, double 1 and followed by 8 zeros and 1 zero. So by using the non-return to zero bipolar technique, that is the odd number of 1 is going to have the non-return to zero polar technique. 1 is going to have the positive amplitude, 0 is negative, again it is positive, and it is going to be transmitted DC 0 is transmitted with the negative 4 zeros, again it is positive amplitude, here it is positive, again these are all the negative amplitude. Okay, so then it becomes positive, and here it is negative. So the AMI, alternate mark inversion. So AMI, that is what the one more name for the bipolar, that is odd number is positive and the even number is negative, and 0 is represented with the DC level 0 volts. So the next previous is the bipolar inverted of that. It is here it is negative and here it is positive and negative, and here it is after transmitting after following 8 consecutive zeros. So earlier it was negative and here it is going to be a positive polarity. So by applying the B8ZS, so B8ZS is going to follow the bipolar. Here it is going to positive and negative, and followed by 4 consecutive zeros. It is not applicable for 4 consecutive zeros. So here it is plus and here it is minus. Now it come into picture, that is earlier one we consider it as a negative polarity. The polarity becomes 0 plus 0 because it is going to follow here. So plus 0 V. B is nothing but the bipolar bit, that is why balancing bit, that here it is become negative, here it become positive, and the 0 again V is going to follow the B, so it is positive, and it is again it is B. Okay, this is going to be a B3 ZS line coding. So whereas HDB3 come into picture when it is for 4 consecutive zeros. So here we are receiving the 4 consecutive zeros. Earlier we have considered as odd number of 1, the coding is 00B, which is going to follow the earlier one polarity. So next is it become the 1, next become 1, it is positive, negative, and since it is a even number of 1 before consecutive zeros, so this code becomes B00V, and here it is B00V, and the next one become positive and it is 0. So B00V, it is positive. Here you can see the earlier it is negative, this is going to be positive, and V is going to follow B because it is violating the rule of bipolar. So this is going to be a positive, and B00V, here you can see that it is a bipolar bit, so the inversion of V it is going to consider, that is negative. and V is going to follow the B, so here it is negative. So this is what the Manchester coding the coded mark inverted bits is going to be the other line coding technique. So this is example for B3ZS, B8ZS coding. So 1 followed by 8 consecutive zeros is applicable, taken as 00V, that is negative. Here earlier it is considered as a negative. So B become positive, and here it is 0, and we follow the positive on B, and here it is negative, and here it is positive. So this is example for B3ZS line coding. So the original data, it is 1 followed by 4 zeros, and 1 followed by 3 zeros, and 1 followed by 3 zeros, and double 1 followed by 4 zeros, So this is the line coding technique. This is a bit streams. So that is the original data is going to be converted into a bipolar technique. So later it is going to be converted to B3ZS. It is considered as the odd number of 1. So then it becomes 100V code, 100V, and the fourth 0 written as it is, and this becomes, earlier we have considered negative, this becomes 1, 1, okay, positive, and the 4 zeros, here it is going to be 0 0. So it is considered as 00V again, 00V. So next it is plus minus. Okay, so these are considered as B0V. So this is considered as B0V, and this as it is 0 minus. So this is about B3ZS line coding technique example. So the next we can see, that is a B6ZS line coding. That is a 0 minus plus minus depending on the previous polarity of the bit. So this is a bit stream you are observing, that is 1 followed by 6 zeros, 1 0 double 1, okay, followed by 12 zeros, followed by 15 zeros and 1. So if you consider the previous one as negative, this code becomes 0 minus plus 0 plus minus plus 0 plus 0 minus plus, and here it is 0 plus minus 0 minus plus, and here it is 0 plus minus 0 minus plus 0 0 0 minus. So minus plus 0 plus minus 0 minus plus minus 0 plus minus 0 minus plus 0 plus minus. So 0 minus plus 0 plus minus, and followed by 3 zeros and plus. This is about the B3ZS coding. So here you are observing followed 6 zeros. So since the previous bit is 1, which code it is going to follow? It is 0 minus plus 0 plus minus. And if it is plus, here you can see this is the plus, which code it is going to follow? 0 plus 0 minus plus, and it is invert of it. So next it is going to follow 0 plus minus 0 minus plus. Okay, since the earlier bit is positive, it is going to retain the same as 0 minus plus 0 plus minus. This is about B3ZS coding. So if you are going to consider it as a negative, then it is 0 plus minus 0 minus plus. Okay, so the negative and this bit as positive, then it is 0 plus minus 0 minus plus, and it is going to followed as invert of it. So earlier bit is negative, and here it is after 1. So here it is we are receiving as positive. This is going to be follow the bipolar rule. This becomes negative. 0 plus minus 0 minus plus 0 plus minus, and 0 minus plus 0 plus minus, and 0 0 plus. So this is example of B6ZS line coding. So 0 0 1 followed by 6 zeros, followed by 7 zeros. Okay, so 1 0 1 1. This is the bit stream. So the original data is going to be converted to a bipolar line coding. So after substitution, since we have considered it as negative, the code is 0 minus plus 0 plus minus. So before, if you consider the positive, this becomes 0 plus minus 0 minus plus. Okay. So this is another example regarding B3ZS. The input data as 1011. followed by 6 zeros, 1 0, 1 0, 1 1. So the last bit is positive, then this becomes a 0 plus minus plus 0 plus minus 0 minus plus 0 minus plus. So this is going to be considered if the last bit has a 0 plus negative, it's plus 0 minus plus minus 0 minus plus 0 plus minus 0 plus 0 minus plus. So the binary input signal has 1 0 followed by double 1 followed by 6 zeros and 1 0 1 0 1 1. So it becomes minus 0 plus minus 0 minus plus 0 plus minus plus 0 minus plus minus. So plus 0 minus plus 0 plus 0 minus minus plus minus 0 plus minus plus. So this is what the binary input signal. So this is the two line coding technique B3ZH. This is not there in the syllabus. Nothing to worry about that. Okay.